Hi guys, so what we're going to do today is we're going to look at the last two conic sections that we haven't reviewed. Those are going to be parabolas and hyperbolas. We're going to start with parabolas just because you may be a little bit more familiar with them because you've been seeing them a little bit longer. You first saw parabolas when you did quadratic equations, actually in Algebra 1 even. A parabola is just the set of all points that are equidistant from a line and a point. That line was called the directrix, that point was called the focus. You guys may be just more familiar with seeing this shape. So a parabola was something that looked like y equals x squared, looks something like that. That's your parabola. So the first thing we're going to look at is vertex form and standard form. We can use either of these, and they're actually very similar equations. They're just rearranged a little bit differently. So vertex form would be in the form of y equals a times x minus h squared plus k. Your vertex here is hk. Just like the center of your circle and the center of your ellipse were hk, your vertex is also hk here. Now a, that's just a value that changes how wide or how narrow that parabola is. We also use that a value to determine what your focus and directrix are. Now you may see this rearranged in standard form. Very, very similar. It would just be written a little bit differently. It would be y minus k equals a times x minus h squared. So just moving that k to the other side. The reason you may see it written this way is because that makes it more similar to your other conic sections, because all your other conic sections were y minus k and not a plus k at the end. So that's why you could get a little bit confusing sometimes. So it may be easier, especially when we look at the sideways parabolas, it may be easier to look at standard form. Now your parabolas can open one of two ways, written in this form, if you have a positive coefficient in front of your x squared. So if you have a positive x squared, those parabolas are going to open up. If you have a negative x squared, those parabolas are going to open down. Now that's some of the stuff you saw in Algebra 1. You also may have seen a form for these where you saw y equals ax squared plus bx plus c. Now when it comes to conics, you may not see that as much, but that is still a parabola, and we actually can still find the vertex from that equation. The vertex of that equation, we would use the equation x equals negative b over 2a. And what that would do is that would give me the x-coordinate of my vertex. Then I can take that x-coordinate, plug it back into my y equals equation, and that would give me the y-coordinate. Now, when you've also learned about conics, you guys saw there's actually two forms. You not only have parabolas that open up and down, but when you look at conics, you also have parabolas that open left and right. What made these different is that they actually weren't functions, because if you have a graph that looks something like this, it's not a function because it doesn't pass your vertical line test. But we can still write these equations. What we'll do is we'll write these in terms of the y component being squared, and that's how they're going to look a little bit different. So standard or vertex form here would be x equals a times y minus k squared plus h. Now this is the reason why vertex form can be a little bit confusing, because the h is now over here in positive and the k is over here in negative, and that can get a little bit tricky for some people. So it may be easier for you guys to use standard form when you're dealing with these sideways parabolas. So standard form would be in the form of x minus h equals a times y minus k squared. And again, this could be helpful just because you're subtracting both the x and or both the h and the k, though you don't have to remember which one's plus and which one's minus. It's always minus, so it's a little bit easier to find your vertex in that form potentially. All right, now which way it opens? If this is a positive y squared, then it's going to open to the right. If it is a negative y squared, it is going to open to the left. All right, so let's look at a couple examples of actually drawing the graphs of these parabolas. So here we have a parabola. This is written in vertex form, and if you didn't understand what I was saying about it being a little harder to find your vertex, for the sideways ones, this is an example right here for you guys. Alright, so what we know first of all, the easiest way to graph these is to determine the shape, the vertex, and then any additional information to help you get a clear picture. The first thing you'd probably do is the shape, and that's just which direction does it open. Is it sideways? Does it open right, left, up, down? So in this case, the y is squared, so this is going to open either left or right. And because the coefficient of the y is positive, this parabola is going to open to the right. Then this graph is in vertex form. So in vertex form, it's hk. My h is -2. My k is a +5. If this were written in standard form, it may be a little easier to see because, again, it would always be the opposite sign. So that's how you get your -2,5 in standard form. Okay, so it's real easy to switch between the two if you need to in order to find what that's supposed to look like. All right, so that's enough to get me started on my graph. I can go ahead and plot the point -2,5. And I know it's going to open to the right, but I don't know how wide or narrow this graph is going to be, so I need to find some more information about it. In this case, probably the easiest thing to do is going to be plotting some more points just by making a table. And to make this even easier, since the y component here is squared, it's actually going to be a little bit simpler to plug in y values instead of plugging in x values. Because with our x's, since this isn't a function, I could get more than one y associated with every x, which is a little bit different than what we're used to seeing. So what I'm going to do is I'm going to pick some easy y values, like I'm going to start with 6. Because if I plug in 6 to my original equation, that gives me 1 squared times 2, which is 2. And actually here, let me plug it into your original there, make it a little easier to see. So that's 2 times 1 minus 1, which gives me 0. So when x is equal to 0, y is going to equal 6. All right, then I also could plug in another easy y value. I could try 7, or if I want to see what the other side of this parabola would be, let me plug in a lower value. Let's go with 4. So if I plug in 4, that gives me a -1 squared. If you square a -1, it becomes positive. So then I just have 2 minus 2, which is again 0. So I know that graph is going to go through these 2 points, and that's enough for me to get a pretty clear picture of what that parabola is going to look like. All right, let's look at this next one. This one is actually in the form you guys are used to seeing for all your quadratic equations. So this one we could figure out our vertex still and our shape just like we've been doing, but we actually could find other information just using what we know about quadratics. So first of all, we know this is a positive x squared, and positive x squareds are going to open up. Then we need to find our vertex. Now there's 2 ways we can do this. One is we can go ahead and put this equation in standard form. If you want to put this equation in standard form, you're going to need to do what's called completing the square. And it may have been a little while since you guys have done this, but we'll review it real quick in case you guys do want to use it this way. So what I would do is I'm going to go ahead and so what I need to do is figure out what value I need to add to make this x squared minus 2x plus something. I want that to work out to where it's going to be a perfect square, so some binomial squared. To figure out what number I want to add exactly, what I'm going to do is I'm going to take that middle number, I'm going to divide it by 2, and then I'm going to square it. So if I do -2 divided by 2, that gives me -1. -1 squared, that gives me +1. But in order to not change this equation, if I add 1, I either need to add 1 also to the other side, or if I'm trying to put it in vertex form, I need to also subtract 1 from that side. So what that's going to do is that's going to take these 3 terms. These 3 terms can now be written as x minus 1 squared. I can combine these other 2 terms as -4, and now I'm in vertex form. And I can see that my vertex is 1, 4, or 1, -4, sorry. Now, if it's been a while since you've completed the square, you don't really remember, you were never really comfortable with it, the other way you can find the vertex is by using that equation we just talked about earlier, that you actually learned about in Algebra 1, where I can do -b over 2a, and that's going to give me the x-coordinate of my vertex. So my b is -2, so that gives me a -2 over 2 times 1, and I get 1. Then, in order to find the y-coordinate, sorry about that, I take the x-coordinate and I plug it into my original equation. And that gives me the y-coordinate, which is still -4. So I still get a vertex of 1, -4. So I'm going to go ahead and plot that. Then in order to finish this graph, I just need some more information. I can plug in points to see a good picture. What I also can do in this case, and this is written more like the quadratic equations we're used to seeing, this is easily factorable. And if it's easy to factor, it's easy to find the zeros. So this factors into x minus 3 times x plus 1, which means my zeros are at 3 and -1. So I know this graph is going to cross the x-axis at 3 and -1. You also could find your y-intercept pretty easily if you wanted to, just by plugging in 0 for x. So a lot of different things you can do to get a good picture. What's important here is just really understanding which direction is this graph going to open, and how do I find my vertex. That's probably the two most important things here. Alright, so now we're going to look at hyperbolas. So hyperbolas, or actually the standard form is going to look very similar to what it did for an ellipse, but there's going to be one major difference. Instead of having, well, let me go ahead and just write out the first part. It's still going to be x minus h squared over a squared, and it's still going to have y minus k squared over b squared, and it's still going to equal 1. The major difference here, though, is that I'm going to have a minus sign instead of a plus sign. Okay, I'm going to have a minus sign instead of the plus sign. And because there's a minus instead, the order here matters. It matters which one comes first, the x or the y. That's going to depend on my direction of my hyperbola. So you also could see this as y minus k squared over a squared minus x minus h squared over b squared equals 1. So very similar to the ellipse, however, that minus is going to make a big difference on the shape. Basically, instead of these opening, you're still going to find your vertices in a very similar way, but instead of drawing a circle and touching all your vertices, you're going to open out away from your vertices. Now over here, your center, this is just a description of what all those letters stand for, very similar to what they did for your ellipses, okay? HK is still the center, just like it has been for all your other conic sections. A is going to be the distance from the center to the vertex. The vertex is what's going to actually touch my hyperbola. Okay, the hyperbola is actually going to go through the vertex. B is the distance from the center to the co-vertex. Now the co-vertex is not really on my graph, but it's very important for helping us draw a picture of a hyperbola. We'll need it to actually draw it. Then if you look at the steps, sorry guys. Then if you look at the steps below here, that's just some steps you guys can follow to help you guys make it a little bit easier to actually draw these graphs. And these are the steps that we're going to use on our next example. Alright, so if you guys look here, we have one hyperbola example. And I'm going to go ahead and follow these steps. Alright, so the first thing it tells me to do is to plot my center. Okay, the x is with the x, alright? Whatever is over, it's not which one comes first. The x coordinate is going to be -1 because it's with that x over there. So my center is -1, 2. So I'm going to go ahead and plot the point, -1, 2. Then the next thing I do, it tells me to use A and B to plot the vertices and the co-vertices. So I'm going to start with A. A is going to be the square root of the number that comes first. So A is going to be 2. So from the center, I'm going to go up and down 2. I'm going up and down, not because it comes first, but because it's with the y. So I'm going to go up 2 and down 2. And those are going to be my vertices. My graph is actually going to touch those 2 points. Now I'm going to find B, and I'm going to do my co-vertices. So B is going to be 5. So my co-vertices, because it's next to the x, okay, because it's next to the x, it's going to go side to side. So I'm going to go left and right 5. Now my graph is not actually going to touch these points. However, these points are very important for actually drawing my graph. Okay, so the next thing that we're going to do is we're going to draw a box. Okay, so we're going to draw a box that goes through the vertices and the co-vertices. And I'm going to make this box in a very light pink color, and I'm going to make it a dotted line. Because again, this is not part of my graph. It is just helping me to draw my graph. Alright. Once you have your box, then you're going to draw your asymptotes. Alright? So my asymptotes, again, still not part of the graph, but if you remember from rational functions, the asymptotes help us to understand what the ends are going towards. So my asymptotes are going to go basically from the corner of that box to the other corner of that box. And that's not a very good dotted line, but you guys get the idea here. Alright, and the last thing I do is I determine the shape and I draw the graph. Well, if you remember when we plotted the points, the ones that came first, those were the actual vertices. Because the y comes first, alright, the y comes before the minus sign, this hyperbola is going to go up and down. So I'm actually going to touch those purple vertices. Now what's confusing about hyperbolas is that those two purple lines that I drew, those are actually the only part of the graph. But the pink box, the yellow asymptotes, the green co-vertices, that's all the stuff I need to actually be able to draw that graph. They're kind of the clues to help me see what this shape is actually going to look like. Now I know there's a lot of steps to this. Just remember it's very similar to the way you did an ellipse. In fact, if I just connected those 4 dots there, I would have an ellipse. Alright, the different process here is I draw the box, I make the X through the box, and then I draw my hyperbola. So let's do one last example since these are very different. And this one is actually also good because it's not already written in standard form. If you guys remember, standard form for both hyperbolas and ellipses should always equal 1. Since this doesn't equal 1, I need to divide by 144 so that this will equal 1. Now I can simplify. This can become x squared over 16 minus y squared over 9, and that's going to equal 1. So it'll be a little bit easier for me to work with. Now I can find my center pretty easily, and I can find my a and b values. So let's start with that. Your center here should hopefully be pretty simple. Okay, there's no shifts, there's no changes. Your center is just 0, 0. Alright, then let's look at our a value. Okay, our a value is going to be the square root of 16. It's with the x, so that means I'm going to go side to side 4 in both directions. And remember, those are the points my graph is actually going to touch. This is going to be a sideways hyperbola because the x comes first. Alright, then we're going to find our co-vertices. These are going to help us draw our box. So the co-vertices, I'm going to use b, square root of 9, which is 3. It's next to the y, so I go up and down 3. Then I'm going to draw my box. Once you have your box, you can draw your asymptotes. And then once you have your asymptotes, draw your graph. We already said this is going to open side to side because the x came first. And there's my hyperbola. Alright, so we'll do some more practice on this in class. I know it might be a lot, especially if you don't remember this very well from last year, but we'll do a lot of practice and it'll get a lot easier as you go. Just make sure, especially for the hyperbolas, you may want to write these steps down so that you remember how to work these out.